So we are looking at more graphing today of our parabolas, but this time, instead of being that standard form where we saw the x squared and then the x and the number, we're in what we call vertex form. Now, vertex form is one of the reasons why we spend time with completing the square. For some students, they're going to use the complete the square process to put it into vertex form because it's a faster way to graph. You just have to do the work of completing the square first. So, vertex form, here it is. Let's talk through it here. All right. We do have some things that are kind of familiar here. For example, this number out in front, this 2, is considered the A portion of it. So we're still going to be able to do our 1A, 3A, 5A. And then what we're working on the inside here is this with this is going to give us our X and Y that goes along with our vertex. So what we end up doing is we end up solving because it's inside the parentheses. So if we solve x plus 3 equal to 0, we're going to get a negative 3. So what a lot of people realize is that it's just the opposite. So this is what we end up calling a lot of times negative b. So we're going to take the opposite of it. And then we just use this portion on the outside for the y. We don't have to do anything opposite. So a lot there, all right, but let's kind of walk through it visually as to what's going on. So my vertex here is going to be at the ordered pair, negative 3, because opposite of that positive 3, and then we're going to use that y coordinates, negative 3, negative 1. So I can plot that 1, 2, 3, down 1, there we go. And now I'm going to simply use this 2 for my 1a, 3a, and my 5a. So 1 times 2, 2. So I'm going to the right one. I'm going to go up 1 and then 2 spots. Remember, it's going to mimic it on the opposite side. 3a. So again, I'm going to go to the right one. So 3 times 2, though, is 6. Okay, wait, hold on a second. Oh, no, I did it there. I got it. All right. Sorry. Oh, I lost something there. 2 times 3 is 6. I'm going to the right one. I got to go to 6 more spots. 1, 2, 3, 4, 5, and then 6. What you're going to end up noticing here is that it makes it very steep. All right. And that's because this number is outside the range of negative 1 through a positive 1. So if we think about a number line here, here's negative 1, here's 1. Anything outside here or here is going to get very steep. Anything on the inside between that negative 1 and that 1 is going to end up making it wider. So those are just little behind the scenes actions that we're looking at there. But yeah, it's as straightforward as that when it comes to your graphing parabolas when you are in vertex form, which is why we like it so much, is because vertex form is fast to graph when it comes down to it. So what we could also end up doing is we can set up our tables if we want, but we don't tend to use this particular method because the vertex form is so fast. But we just want to kind of show you how things will end up matching up. So if we're going to graph this here, we can use our normal numbers of like 0, 1, and 2. Problem with that is if we use 0, 1, and 2, that's going to be way over here. That's going to give me numbers that are way up my chart there, which are very... So we still like using the vertex form to give us a starting number. So, for example, I can see it's negative 3. So, yeah, I'll use a negative 4. Yes, I'll use a negative 2. And then we could, if we wanted to, we could go ahead and plug it in and solve. Negative 3 plus 3 is your 0. 0 squared, all right? Still gives me 0. So you can see from this filling out the table, just not very efficient. So as much as I started talking about it, no, we're not going to do that. They give you vertex form, we're jumping to it right away when it comes down to it. All right, so let's try another one that is here. Let's do y equals 1 half x minus 4 squared plus 1. Go ahead, see if you can graph it out, see what happens. All right, so vertex-wise, I'm going to identify here. It's going to be a positive 4 and a positive 1. Again, I'm taking the opposite, and then I'm using this as my x and my y. I'm going to go ahead and get my graph down here. 4, 1, 1, 2, 3, 4, down 1. So there's that vertex. And now I've got my 1a, 3a, and my 5a. Now we're going to get some fractions here, but that's okay. We're looking for a good estimate of where we're at. With the 1, you can see it's going up only 1 half. So when I go to the right one spot, I'm only going up a little. Remember, it's closer to 0. So this is why we're going to start to see it be a wider looking parabola. All right, 3a. So multiply 3 times 1 half, that's 1 1/2. So again, we're going to the right one, all right, but we're only going up 1 1/2. So that's up a half, that's 1, that's going to put me right, oops, sorry. That's only going to, we got to get this nice looking graph that's here. Here we go, something like that. And then again, to the right one, up 1 1/2, there we go. And again, we can see it's starting to widen out. If we do the 5 1/2, well, a half times 5, that's 2 1/2. So again, I go to the right one. I'm just going to kind of estimate here, go up 2 1/2, something about there. So again, we're going to go to the left one. All right, and we're going up 2 1/2, so something right around there. But now you can start to see that we did get a wider graph than before. And again, because that 1 half is our A, and we can see that's somewhere in between -1 and 1, that's why we're getting that wider graph. All right, so let's look at another one here, and let's see what happens when this graph ends up getting flipped upside down. We can still end up using our kind of traditional method here. I'm going to go just a negative and then x minus 3 squared and then minus, let's go minus 4. So when I graph this particular one, I can see right away my vertex is at 3, -4. And again, opposite, there's your positive 3. We're going to use u, so there's my -4. So 1, 2, 3, 1, 2, 3, 4, so someone right around there. It is negative, so it's going to get that upside down looking shape, but I can still do my 1a, my 3a, and my 5a. And we'll see when the negative comes into play here. So 1a, 3a, 5a. So this really is a -1. So 1 times negative. So again, we're going to the right one, but now we're going down -1. So we're going to go to the left one, we're going to go down -1. 3a, we're going to go to the right one, but we're going to go down 3 that we're looking at. Again, we're just going to kind of estimate here as we're looking at it. So again, to the left one, and then make 1, 2, 3, there we go. And then the right one, down to your 3, that's there. And we'll kind of get our typical picture of our parabola because it is just a 1 out there. Negative, so it's going to end up flipping it here. All right, we're going to use the same, I'm going to use the same graph just to show you how things can end up changing here. And let's go -3, and then x, let's go x plus 2, and then we're just going to leave it at that. So this particular one, we're going to notice your vertex opposite, so it's -2. I don't have anyone out here. Well, what number is that then? Well, that's going to be a 0. So -2, 0 is my vertex. I can still do my 1a, 3a, 5a, but this is going to let me know the negative. It's going to be flipped, and it's going to get steep because it's that 3. That's outside that -1 range that we got up there. So when I do my 1a, all right, yeah, I go to the side 1, but I'm dropping down 3 now. So we're right here. Going right 1, 3, okay? 3a is my next one. So 3 times negative 3 is negative 9. I'm going to the slight one, then 1, 2, 3, 4, 5, 6, 7. Yeah, you can see what's going on here. All right. Look how much steeper this particular one got as a faster there. So it is something to be aware of. It's something we want to have in the back of our heads of what it should end up looking like. Like, we should be ready for it to be flipped. We should be getting ready for it to get tighter in between, narrower that's there. Again, it's a faster process here. So we like vertex form. It helps us graph much quicker than being in standard form.